So what we're going to do in this section, guys, is we'll be doing only two trig graphs. You should be thankful because we're doing the two easiest trig graphs, sine and cosine. They're really very similar. Tangent is more complicated, and it gets much more complicated when we get into secant, cosecant, and cotangent. We're not going to go there. So we're only going to graph sine and cosine. We're going to spend 5 lessons doing that, okay? Because we're going to add sort of something every day to the graph to make it a little bit more complicated so you can graph any sine, cosine that you're presented. The reason we do this, guys, is that in trig, there are a lot of things that can be modeled with sine and cosine. If you have Wi-Fi in your house, that travels through sound waves. So it travels in waves like this. The waves hit the wall. That's why you get a bad coverage in a certain part of your house. This all travels in waves. So we could model this with sine and cosine waves. Voltage, sound, rotation of objects, like a wheel that goes round and round. These are all things that we can model with sine and cosine graphs. So the unit circle, we're going to make it a little bit simpler. What if the unit circle had been this? How easy is this? I mean, this is part of it. So I've pulled out the pi over 3, pi over 4, pi over 6. Those are all gone. If you can remember this part of the unit circle, you can graph any sine or cosine function. So this is 0. That's pi over 2. This is pi, 3/2 pi. Label all of those coordinates. That's all I need to be able to graph one of the trig functions. Now, let's graph one. Let's take the first one. I want to graph the sine of x over the interval 0 to 2 pi. Okay? So what I need to do, let's just figure out if x, I'm going to pick an x value. If x is 0, okay? Go look at 0 on the unit circle. The sine corresponds to what value? The y value. At 0, what is the y value? Here's 0 radians. What's the y value? 0. Okay. Now the next spot I'm going to go to in the unit circle is pi over 2. At pi over 2, what is the y value? Did someone say it? 1. Okay. Now I'm going to go to pi. At pi on the unit circle, what is the y value? 0. Okay. At 3/2 pi, what is the y value? -1. And at 2 pi, what is the y value? Y value is 0. Okay? So all I did was go all the way around the unit circle. The y value was 0, 1, 0, -1, and 0. And this is what I'm going to graph. Okay? So what you see here, this is my x-axis, and up here is my y-axis. So I'm just going to plot these points. Okay? The point 0, 0, that's this point right here. Okay? What point do I plot at pi over 2? What point? Pi over 2, 1. So pi over 2, 1 is this point right here. Okay, what do I plot next? Pi 0. And then what? 3/2 pi, -1, and 2 pi, 0. Okay? Now, this is where, when you draw this, this is what I don't want to see. Okay, that's not what this graph looks like. Got to take a little bit of care with it. This graph has a curve to it. So this graph goes up, it comes down, and it curves, and it just keeps on going. Okay, that's it. Okay, so think of it as a nice sloping hill. Okay, or a bowl, whatever you think of it. Now, if you think about this, in the unit circle, this is 2 pi. This is also 4 pi, 6 pi, 8 pi. In the unit circle, I keep going round and round, right? Okay, so this graph just keeps on going. Instead of going round and round, I've stretched it out to graph it on an xy plane. So this is what the graph of sine of x looks like. Now, what you need to know, and it talks about it in the book, I think the next paragraph, it is very helpful for you to be able to describe this graph. Okay, and by describe it, this is what I mean. What's the y value here? What's the y value? 0. Okay, this graph starts at 0 and it ends at what? 0. Okay. Halfway in between, it's also at what? Here. Okay, so this graph starts at 0, it ends at 0. Halfway between, it's also at 0. Halfway between these 2 points, where does it go? Up 1. Halfway between these 2 points, where does it go? Okay, that's how you describe a sine graph, okay? Because what's going to happen, this graph is going to move around, it's going to stretch, it's going to get bigger, but if you know it always starts at 0 and it ends at 0. Halfway in between is 0. Halfway between the first 2 points, I'm at 1. Halfway between the second 2 points, I'm at -1. If you can think of the sine graph that way, then you'll be able to graph it as it moves around in different places. Okay? So let's take a look now at how we would graph the cosine curve. So again, I've got x values. What's the definition of cosine? It's the x coordinate. At 0, what is the x coordinate? 1. Okay, at pi over 2, what is the x coordinate? 0. At pi, what is the x coordinate? -1. At 3/2 pi, what is the x coordinate? 0. And at 2 pi, 1. So I need to graph this particular function. So I start out at 0, 1. Pi over 2, what? Pi over 2, 0. Okay. And what's at pi? -1. 3/2 pi, 0. And 2 pi, 1. Okay. Again, what I do not want to see is this. It is not a V. Okay. This graph also is a curve. So this graph is similar to what you see there. It's doing something like this. Okay. So these graphs are they're basically curves that go like this. You're basically just seeing a different part of the curve. So if you look at the sine graph, you know, it's like the cosine, it's like it starts here and then it goes back up. Okay, so you're just basically seeing different sections of the same curve. Now let's describe the cosine graph. Somebody describe. It starts at what? Well, no, what is this? 1. It ends at 1. Halfway in between, it's at -1. And then halfway between these first 2 points, I'm at 0. Halfway between the second 2 points, I'm at 0. Okay, so the sine graph starts at 0, ends at 0. Halfway in between, it's at 0. Halfway between the first 2 points is 1. Halfway between the second 2 points is -1. Cosine starts at 1, ends at 1. Halfway in between, it's at -1. Halfway between these first 2 points, I'm at 0. Halfway between the second 2 points, I'm at 0. So if you can describe the graph in that way, it helps you when this graph moves around and moves to different places, okay? Now, there's another piece we're going to talk about that describes these graphs. So we're building up to, remember how we graphed polynomials and we had like reflection about the x-axis. It moved to the left, it moved to the right, it moved up, things like that. We're basically going to do all those things with sine and cosine. We're going to do them in pieces. So one piece we're going to talk about today is called the amplitude. Okay, the amplitude is, if you look at a sine graph or a cosine, how far up it goes. Okay, so from 0, how far up this graph goes. So in this graph, this was our sine graph. So if you look at our sine graph, what's the distance from here to here? 1. Okay, and the distance from here to here? Well, in distance, we'll call it positive. We'll say it's 1. Okay, it goes in a negative direction. So what we will say is for this graph, the amplitude is 1. Okay, so when you're at 0, to get up to the highest peak, you only go up 1. To get to the lowest valley, you only go a value of 1. So the amplitude of this function is 1. Same thing with the cosine graph that we just graphed. Here's 0. How high up do I go? I only go up 1 unit. How low do I go? I only go down 1 unit. The amplitude is 1. I only go at most a distance of 1 away from 0. Now, what do you think this graph is going to look like? 2 sine x. let's graph the points again. So at 0, what's the y coordinate? 0. Pi over 2. Pi. -1, 0. Now, if I want to graph 2 sine of x, what's the difference between sine of x and 2 sine of x? Multiply by 2. What happens when you multiply this number by 2? Multiply this number by 2. 2. 0. Multiply that by 2. -2. Multiply that by 2. I get 0. Okay? So multiply the numbers by 2. So now I want to graph 2 sine of x. So I'm going to graph, let's graph these as my xy coordinates. Okay? So what's the first point I need to graph? 0, 0. What's the next point? Pi over 2, what? 2. Okay. What's the next point? Yeah, pi 0. 3/2 pi, what? -2. And then 2 pi 0. Okay. So if I were to graph this, this graph looks like this. Now, it's the same shape as what I graphed a moment ago with the sine. So it starts at 0 and it ends at what? Halfway in between, it's at halfway between these first 2 points, it goes up to 2. Halfway between these, it goes down to -2. Yes. You can, yes. So it does continue going. So what's the difference between sine of x and 2 sine of x? It's multiplied by 2. So instead of going up to 1, it goes up to 2. So it just goes up higher. So it's like I took the graph and I pulled it in this direction. Okay? So if I look at anything like this, if I look at any of these graphs, f of x equal some number times the sine of x or some number times the cosine of x, these graphs have an amplitude of the square root of a. Okay? So if I look at this, this was 2 sine of x. The amplitude is the distance from here to here. What is that distance? 2. So in this graph, this has an amplitude of 2. Okay? And it's the same distance here from there to there is 2. So this graph has an amplitude of 2. So from the 0 on the x-axis, I only go up 2 and I go down 2. So the amplitude of this graph is 2. What would the amplitude of 3 sine of x be? 3, okay? So I think there's some questions next that do that. So what is the amplitude of this one? It's 4, okay? The amplitude is always positive. So you look at the number in front and you say, what's the absolute value of that number? That's the amplitude. So if you graph this sine function, it's going to go up to what number? How high will it go? 4. It's going to go up to 4 and down to 4, okay? What's the amplitude of this next function? Square root of 2, okay? So instead of going up to 1, it's going to go up to square root of 2. What's the amplitude of the next one? 6. You're just basically looking at whatever number is in front of this and writing the positive value of that. Yes? Amplitude's always positive. What's the amplitude of the next one? 1/2. What's the amplitude of the next one? Pi. And the last one? 4. Okay? So that tells you when you look at this graph from the x-axis, it's going to go, the height is going to be 4 away from the x-axis and the low is going to be 4 away from the x-axis. So that's the amplitude of that graph. Now, we're going to put something together here. What happened last year when we graphed, this was the dance move of what? X squared. What was this one? Negative x squared. So what does a negative do in front of a function? It flips it. It reflects it about the x-axis, okay? So let's look at this. We're going to see what does negative sine of x look like. So let's go back to sine of x. Remember sine of x. What's the y value at 0? Let's go with 0. Pi over 2, y values, okay, 0, -1, 0. Those are all the y values on the unit circle. Now, Let's find the negative of that. What's the negative of 0? What's the negative of 1? Negative 1. Negative of 0. What's the negative of negative 1? 1 and the negative of 0. Okay. So now what I want to do, let's graph. Here are my x values. Here are my y values. Okay. So the point 0, 0 and the point what? Pi over 2 what? What point do I graph? Pi over 2, negative 1. Pi what? Pi 0, 3/2 pi, 1 and 2 pi, 0. So if I were to graph this function, it looks like this. Now, how does that differ than the sine function? What's different about it? So this, the function in red, this is negative sine of x. Okay. If I were to graph the sine of x, remember what did the sine of x do? It started at 0, it ended at 0. Halfway in between it was 0. Halfway between here it went up to 1 and down to negative 1. So this was, that's the sine of x. So what's the difference between the sine of x and negative sine of x? It's just been flipped, okay? So all that happened was, instead of being at 1, you're at negative 1. Instead of being at negative 1, you're at positive 1. So all that happened to graph from sine of x to negative sine of x is I just flipped the graph, okay? So when I see something like negative sine of x, it's just a reflection of sine of x, okay? So how are we going to work with that in a graph? Let's take a look at an example. So you should get very familiar graphing sine of x, and I really shouldn't have to start picking points every time. That will slow me down. If I can rely on that description, sine of x starts at what? It ends at what? Okay? Halfway in between it's, okay? That's pretty easy, okay? Halfway in between, where does it go? Up to 1. Halfway in between the next two, where does it go? Down to negative 1. That is my sine graph, okay? Now, I need to graph negative 2 sine of x, okay? So that means everything's multiplied by what? Negative 2, okay? What happens when you multiply 0 by negative 2? You get 0. So I know that this graph is going to, when I multiply by 0 by negative 2, I still stay at 0. This graph starts at 0. It ends at what? 0. Halfway in between, it's what? Okay. Now, normally it would go up to 1. What happens when a 1 is multiplied by a negative 2? You go to negative 2. Okay. Normally right here it would go down to negative 1. What happens when a negative 1 is multiplied by a negative 2? You get a positive 2. Okay. So this graph is something like this. Okay. So that's what the graph of negative 2 sine of x looks like. Okay. So you can see I didn't have to pick points to make that happen. If I can know that the sine always starts at 0, ends at 0. Halfway in between it's 0. Halfway in between here is it goes up to 1. Halfway between these 2 points, it goes to negative 1. So if there's a negative, I just flip those values, but the zeros stay where they are. Okay? Pardon me? Yeah, this has an amplitude of 1. This has an amplitude of 2. So this one has an amplitude of 2. So let's graph a few more sine, and then we'll do some cosine. So graphing 3 times the sine of x. So I don't have to graph sine of x every time. You should start to know, where does the sine of x start? Where does it end? Okay. Halfway in between. Okay. So that part you should get. Okay. Now, normally the sine will go up to 1. What happens when 1 is multiplied by 3? Yeah, it's going to go up to 3. Okay. Halfway between these 2 points, it normally goes to negative 1. What happens when negative 1 is multiplied by 3? negative 3. Okay? So this graph goes up to 3, and it does this. Okay? So what is the amplitude of this? The amplitude is 3, because the distance from there to there is 3. Okay? So negative 5 sine of x. What's the first thing that I graph? Graph the zeros. On the sine function, starts at 0, ends at 0. What's the point here? That's 0, okay? Now, normally, it would go up to 1. What happens when 1 is multiplied by negative 5? Okay, you get negative 5 as your answer, which is right here. Normally, it would go down to negative 1 at that point. But what happens when the negative 1 is multiplied by the negative 5? Yeah, positive 5. Okay. So this graph looks like this. What is the amplitude? Yeah, the amplitude is 5. Okay. Pretty straightforward, guys. Right? Now, cosine, I don't think it's a little bit harder. It's just, you know, the graphing, you just got to remember that description is a little bit different. The way we described a cosine graph, it starts at what? It starts at 1, and it ends at 1, okay? Halfway in between, it's at what value? Negative 1, okay? So the cosine starts at 1, ends at 1. Halfway in between, it's negative 1. What is it halfway between the first 2 points? 0. What is it halfway between the next 2 points? Okay, that's my cosine graph. Okay? So it starts at 1, it ends at 1. Halfway in between, it's at negative 1. Halfway between the first 2 points is a 0. Halfway between the second 2 points is a 0. Amplitude of that is 1. So, how would I graph negative 2 times the cosine of x? Okay? So normally the cosine would start at 1, right? What happens when 1 is multiplied by negative 2? You get what? Negative 2, okay? Okay? So normally the cosine graph ends at 1. What happens when 1 is multiplied by negative 2? Negative 2. So this graph is going to start at negative 2 and end at negative 2. What is it going to be halfway between there? Positive 2. So normally halfway between the cosine is at negative 1. What happens when negative 1 is multiplied by negative 2? Positive 2. So this graph starts at negative 2, ends at negative 2. Halfway in between, it's 2. What is it going to be halfway between these first 2 points? 0. What's it going to be halfway between these two? 0. There's your cosine graph. So, something like that. What's the amplitude? Yeah, the amplitude is 2. Okay. So cosine is a little bit different. Like the sine is really nice because you've got starts at 0, ends at 0, halfway between a 0. Your zeros never move when you multiply or when you do translations. Okay. The zeros stay where they are. But the cosine, it starts at 1, ends at 1, so that those points may move at the very beginning, but your zeros still stay the same in the cosine graph. So I think we have a couple more and we are done. Okay. 4 times the cosine of x. First, before we do anything, what's the amplitude? Yeah, amplitude's 4. What's the amplitude of the sine function here? It's 5. Okay. So cosine. Now, if you need to draw the cosine and then draw 4 cosine, that's fine, okay? Some people would do it that way. So let me just try both of these methods. Let's draw, what is a cosine? The cosine starts at what? 1, and it ends at what? Halfway in between, it's negative 1. Halfway between the first 2 points is 0. Halfway between the second 2 is 0. So this is what the cosine function looks like, okay? So that's the cosine of x. So what do you think 4 times the cosine of x would be? Yeah, so what happens when you multiply that by 4? You get 4. What happens when you multiply 0 by 4? Stay where you are. What happens when you multiply, and I made a mistake here. I had mine going down to -2. Let me back up. It starts at 1, it ends at 1, halfway in between is -1, 0, and 0. Okay, so if I multiply by 4, starts here, this stays at 0. What's -1 times 4? Yeah, -4. 0 times 4 and 1 times 4 is here. So this function is something like this. So that's 4 times the cosine of x, okay? So if you can graph cosine of x, and then you can graph 4 times the cosine of x. You can do that on the same graph. Just make sure it's clear to me which one that you're graphing, and you're good to go there. -5 times the sine of x. Sine of x starts at what value? 0. Ends at halfway in between. Okay. Now, halfway in between these 2 points, it normally goes up to 1. What happens when 1 is multiplied by -5? Yeah, it's going to go down to -5, which is right here. And then halfway between these 2 points, it normally goes to -1. What happens when -1 is multiplied by -5? +5. So you get a graph that looks like this, okay? So this graph has been reflected about the x-axis and has been multiplied by 5, okay? So summary of what we did here, you should be able to graph sine and cosine functions that look like this. If I put a number in front of sine or a number in front of cosine, whether that's a positive number or a negative number, you should be able to graph that. The amplitude is just the absolute value of this number in front. And then what's the difference between, if a is a positive number, what's the difference between those two graphs, a sine of x and -a sine of x? They've been flipped about the x-axis, okay? And then similar with the cosine. And there we are.